Hello everyone, welcome to my class. This is lecture 208. Here I want to make you understand that how we'll go for the calculation of thrust if it is a parabolic. So if you see this parabolic twin charge A and B are hinged. So at any point at a distance of x, you can say this is your x and this is your y. We can find out the moment also. But what will happen, this h is integration my ds upon ei and divided by integration y square ds upon ei. Now if ei is a constant, there is no problem. But if ei means I varies, so what will happen? The arch will be something like this, in this way. This is your arch. This is perpendicular in this way. This is, and you can say this is something like this. This is your arch shape. So this is your ds, and this is your dy, and this is your dx. You can say this is theta. So the relation between ds and ds, dy by ds is sin theta, dx by ds is cos theta. So ds is ds by cos theta, dx sin theta. So if I varies, so I will be, if you put I0 sec theta, I equals to, so here the variation will be my sec theta dx divided by ei sec theta. So this will be also like this, and the integration will go for my dx upon ei0 and ei0 y square. So finally we will get this my instead of ds will get respect to dx. So if it can be done for this parabolic arch, that is the h is nothing my dx upon y square dx, because if you go for the ds whole, you open it, this is not integrable, so we go for the approximation. So this is approximation method to find out the horizontal thrust. Instead of writing ds, we write dx. So please keep it in mind, and in further questions we will counter with this equation my dx upon integration y square dx. So thank you for this introductory, and we will take up some problem to solve this type of problem. Thank you very much.